This problem, what we have to do is find like what the compression of the spring is, and the spring is basically this space here, which we're going to call HB. It's pretty simple, but basically we have to start off is by defining what all of these things are structures. And we'll start off, I kind of already did a little something here. Basically, it's the kinetic energy of point A plus the potential energy of point A plus the elastic energy of point A equals the same thing on the other side. The kinetic energy plus the potential energy plus the elastic energy. Since we can choose anything, we can make it seem like if this product A is on the floor, so that would mean that all that would be present is the kinetic energy. This would be 0, this would be 0 as well, this would be 0. We would have to find the height and also that elastic energy that we're talking about. B squared. So let's just say that VA equals 10 meters per second, that K is equal to 1 Newton per meter, and the mass is 1 kilogram. So how would we solve that? We could just plug in the numbers. So we have 1/2 times 1 times 10 squared equals 1 times 10, that's HB, plus 1/2 HB squared, because we don't know what HB is. Now, this is basically equal to 50 equals 10 HB plus half of HB squared. Now, to make this problem easier, we'll multiply everything by 2, so that we have 100 equals 20 HB plus HB squared, of course. Okay, so next what we have to do is basically just simplify it. So what we're going to have here is HB squared plus 20 HB minus 100, and we have to solve for HB, and that's using the quadratic formula. So we have HB equals negative 20 plus or minus the square root of 20 squared, and we say that 4AC squared, 4AC is 400 after simplifying it over 2. So HB equals negative 20 plus, we'll keep it positive, the square root of 800 over 2. And after simplifying all that, we get that the answer is 2.5 meters approximately, and that's the compression of the spring from height A to height B.